Hello everyone, my name is Mengyuan and my project is called Ritual Snake. First, I would like to give a brief introduction to this project. In this project, I use Java and Eclipse to implement this game. This classical snake game contains four major functions. First is initialization of the map, snake, and food. The food must be generated randomly except the snake body. Second is movements of the snake. The user can change the moving direction of the snake by using the up and down, left and right direction keys on the keyboard, and the snake can move in a straight line in the controlled direction. Third is eat food. When the snake head touches the food, it means that the snake is ready to eat this food and get a score. The next food will appear at any position on the map except the snake body, and the user can control the snake to eat this food again. Fourth is death judgment. When the snake head hits the wall in the forward direction, or the snake head eats the snake body, it gives the death judgment. Next, the first architecture style I choose is blackboard style. Here is the component diagram. There are several components which are initialization of snake body, food and map, change direction, movements of snake, eat food and regenerate, record score, death judgment, and blackboard. In this diagram, the initialization of food provided the coordinate of the food and to the blackboard. The initialization of snake provide all the information about snake, which include length of the snake body, coordinates of the snake head, and the direction of the snake movement to the blackboard. The, the, initial, the initialization of map provide the length and the height of map to the blackboard and generate a snake and a food on the map. Movement of snake obtains the direction of snake movement from the blackboard and makes sure that the snake runs following the direction at all times. Change direction means that after receiving the key pressed event like up, down, left or right, it will provide the updated direction of snake movement to the blackboard. And eat food and regenerate it obtains the information about snake and food from the blackboard and check if the coordinate of the snake head equals the coordinate of the food. If so, then it means that the snake has eaten the food and this component will generate a new food on the map except the snake body. It will provide the updated coordinate of the food and the length of the snake to the blackboard. Record score obtains the data about snake and food too from the blackboard and to check if snake has eaten the food. If so, it means that player gets score and it will provide the updated score to the blackboard and display it on the screen. Death judgment obtains the information about snake and map from the blackboard. Finally, the blackboard contains all the data about this game, including like length of the snake body, area list of snake, coordinate of snake head and food, direction of snake movement, etc. Here is the class diagram for the blackboard style. There are four classes for this game, which are snake, food, map, and data. In snake class, there are 6 variables, which are length, snake, live, direction, x and y. They represents the length of snake, snake body, whether the snake is alive, direction of snake movement, and coordinate of the snake head. For direction, I use int variable, which means that 1 represents up, 2 represents down, 3 represents left, and 4 represents right. Besides, there are 5 methods in the snake class, which are snake, run, get, direction, change direction, and get size, and I think most of them are self-explanatory. Snake method is responsible for the initialization of the snake body. X and Y means the height and width of the map. This method would calculate the coordinate of the snake head based on the size of the map because the snake body would always be generated in the center of the map. Round method is responsible for keeping the snake moved towards the direction of head. For food, x and y represents the coordinate of the food, and the food method represents the generation of a new food randomly, except for the snake body on the map. For map class, x and y represents the height and width of the map. There are also two kinds of variables, which are snake and food. For the method part, display score shows the current score in the game, and the map method represents the initialization of the map. Besides, in data class, it contains all the information of this game, including direction of snake, size of snake, coordinate of every segment of snake, body and food, the current score, whether the snake is alive, and for the method part, the first three methods represents whether the snake eat food or hit the wall and gets the live or die status of the snake. Next is the mapping between components and classes. And I think this slide is very straightforward. Those different methods is related to different components, and I just talk about some of them which is more important, like eat food and the regenerated component is related to is eaten food method from data class and the food method from food class. And the second option I choose is MVC. Here is the component diagram. Model component contains all the information of this game, include direction of snake, length of snake, coordinate of snake, head, coordinate food, status of snake, live or die, etc. View component is responsible for display the game, including map, snake, and food. Controller component is responsible for respond the key event from the keyboard. As for the interaction among them, views can get all the information like location of food and snake and direction of snake from the model and display them on the screen. And the models can update those data according to the current status of snake and food from view. Which with such real-time data, model can judge whether snake eat food or hit a wall or hit itself. For controller, it will respond to the key event from keyboard and change the data in the model based on the event type and change view indirectly. In this case, user can press up, down, left, and right to change the direction of the snake in the model. Press R to restart the game and press space bar to pause the game. Next is the class diagram for MVC and mapping between components and class. I think mapping is very intuitive. There are three kinds of classes, which are snake model, snake view, and snake control. They represent those three components separately. For snake model class, the Boolean variable matrix represents whether there is a snake or food on the position. Node area represents the snake body. Max, X, and Y represents the height and width of the map. For int variable direction, it means it is the same from the obvious previous slide, and 1 means left, 2 means up, 3 means right, and 4 means down. Running represents the running state. Snake model is the initialization of all this data. Move on enable the snake move towards the direction of head, and run controls and the pause or running state of the game. For snake view, main frame represents the game window. Paint canvas represents the map. Canvas width and height represents the size of the map. Node width and height represents the coordinate of the food. For method part, repaint is responsible for the drawing of the map, including snake and food. Drawing node means generation of the food. For snake control, it contains a snake model variable and a key pressed means the detecting all possible key events from keyboard and responded quickly. In this slide, I will compare the pros and cons for these two methods. For Blackboard, its advantages is that it provides a data access to store all the information in this game, and it is easy to query and change those information about snake, food, and map. Besides, it can provide safety and a low error rate because change of data status is based on the change or query of information in the database, and it's easy to evolve and has high usability because if you want to change the color of the snake or food, all you need to do is accessing the database and change the related data. Those logical code of interaction can remain the same. However, it has own limitations, which is that it cannot support real-time response requirement of this game. Besides, high-frequency access to the database will lead to serious system performance problems. For MVC, its advantages are obvious. First is low coupling. The view layer is separated from the model layer, which allows you to change the view layer code such as the color of map or food or snake without recompiling the model controller mode. Similarly, the model is separated from the controller and view. It is easy to change the data about snake, food, and map and the interaction rules of this game without concerning about view and controller. Second and third is high reusability and easy to evolve. For instance, in the future, if I want to turn this game into a multiple levels game, in every level the shape of the map is different, the color of snake and food is different, or there are some barriers in the game, in the map, etc. Then MVC can enable you using a variety of different styles of views, and the current code of this game, especially the logical part, can also be used too for future updates. However, MVC has its own disadvantages. It increases the complexity of the system structure, and maybe it's a little bit difficult to implement a system using MVC. Besides, using MVC framework will cause the view layer to access the model layer and get the data. It needs to call the method many times, which will reduce the running efficiency. Finally, I choose MVC to implement this game. There are several reasons why I think so. First, for this game, it has an important non-functional requirement, which is short response time. No one wants to wait for more than 1 minute, 1 second to see the movements of the snake after pressing the arrow keys. Obviously, Blackboard can't handle with this requirement. Second is that using Blackboard may be a little bit redundant for this game, because this game mainly focuses on the action of snake, the interaction, rather than those data or attributes. Although those information are very important, but players don't care about them because you can't even see them. If using Blackboard, then there are 3 steps for the system to do after receiving a key event from the keyboard. First, the system tries to access the database, then get the needed data or change data, then the system give a response based on those data. But for MVC, it only have two steps, key press, and then system can make a response. The accessing to the database is redundant and slow. Third is future evolution, like I've talked before. Like if I want to turn this game into a new 3D version, Retro Snake, then MVC can provide high visibility. I can share all those views and controls and models. Next is a screenshot of the successful compilation of this game, and as you can see, there are no errors. Finally, I'm going to show this game. Here is the project. As you can see, I'm going to show this game. As you can see, I can use the arrow keys to change the direction of the snake. Left, right, up and down. And then I can control the snake to eat food and get a score. Besides, I can press space bar to pause the game, or press R to restart the game. I can press R to restart the game, and page up and page down to accelerate to or decelerate the game. And finally, if I hit a wall, then the game gives a death judgment, or if the snake hits itself, it will also give a death judgment. So that's all about my project. Thanks for watching.